Okay, so to solve these inequalities, well, to be honest, in general, when you're solving inequalities, you are solving them in pretty much more or less the same way as which you would solve an equation, with a few little things to be wary of. But I'll let you know about those things as and when we get closer to those things.
Okay.
Okay. So first one, x plus 4 is greater than 9. So first thing we want to make sure we do is make sure that the sign is facing the same way each time. We shouldn't flip the signs or try to avoid flipping signs if it's possible. So
Okay.
I've got x plus 4 is greater than 9. So to get x by itself, I'm going to take away 4 from both sides. And that's just going to give me x is greater than 5. That's the solution to the first one. Done.
Okay.
Okay. Uh, what about the second one?
Um, you add 3 on both sides,
Uh-huh.
and that's x.
Yeah.
X is smaller than 5.
Yep. Very good. X is less than 5. Second one done. Third one.
Um, divided them both by 2.
Yep. So we get that x is less than or equal to.
7.
Yep. Very good. And then the next one.
Sorry, 1 second.
No problem.
Divide both sides by 8.
Yep. So x is less than.
8. 2.
Yes, x is less than 2. Brilliant.
Can I copy it down quickly?
Yeah, of course. By the way, all of this stuff will be on the Jamboard, so it will be there for you. Like you're not gonna lose this.
Okay.
Also, I'm gonna upload this onto YouTube, so you'll be able to see everything and hear the explanations as many times as you need to.
Okay.
But if you want to write it down, that's fine as well.
Okay.
Cool. All right. So the next one is just as simple as dividing both sides by 5. So x is greater than or equal to 3. And the next one?
Times them both sides by 3.
Yep.
So x is greater than 12.
Very good. G?
Times them both sides by 5.
Yep.
X is smaller than or equals 10.
Lovely. And then the next one?
Minus both sides by 6.
Mm-hmm.
So x is greater than
Mm-hmm.
or smaller than minus 2.
Greater than or smaller than, did you say?
I mean, or equal
Uh-huh.
to minus 2.
Yes, the -2. So all good so far. I think it's fine. Next slide. A little bit more work, just 2 steps instead of 1 step. So if we go for the first one, taking away 1 from both sides gets us 2x is less than or equal to 8. And then dividing by 2 gives us x is less than or equal to 4. All good?
Yeah.
Lovely. Okay. Next one.
Add 5 to both sides.
Mm-hmm. So we
So
get,
that's 3x is greater than 21.
yeah.
Then divide both sides by 3.
Mm-hmm.
So that's x equals 7.
X what?
Greater than 7.
Yes, greater than 7. So always want to make sure that we do not put equals or change it for anything else. We keep the sign exactly as it is.
Mm-hmm.
Cool. Nice. On to the next one, I guess.
-8 from both sides.
Mm-hmm.
24. 4x
Mm-hmm.
smaller than 24.
Mm-hmm.
Then divide both sides by 4.
Mm-hmm.
X is smaller than 6.
Yep. Very good. The next one.
Add 2 on both sides.
Very good.
So 5x greater than or equal to
Mm-hmm.
70.
Yep.
Then divide 5 on both sides.
Mm-hmm.
14.
Yes. So
Okay.
am I writing?
X is greater than or equal to 14.
Yep. Very good. Nice, nice. Next example. We've got the fraction, so just going to take away 1 from both sides, giving x over 2 is less than or equal to 4. And then multiplying both sides by 2 gets us x is less than or equal to 8. Mhm.
Add 6 to both sides.
Uh-huh.
So that will be x over 9 is greater than 10.
Mm-hmm.
Then times 9 on both sides.
Mm-hmm.
So that's x is greater than 90.
Mm-hmm. Very good. Lovely, lovely stuff. Okay. Next one.
U times 2 on both sides.
Mm-hmm.
So that's x plus 3
Yep.
is greater than or equal to 10.
Yep.
Then minus 3 on both sides.
Mm-hmm.
So x is greater than or equal to 7.
Nice. Yeah, on fire. On fire. And then the last one, we multiply both sides by 2. So we get x minus 5 greater than 8. And then adding 5 to both sides gives us x is greater than 13. You've got this, yeah. So that's like solving basic-ish inequalities. Even these next ones, to be honest, they're not even that bad, I don't think. But except the only thing we want to do, which is on slide 3, is just know how to represent these on a number line, and I'll show you how to represent those.
Oh yeah, that's what I had trouble with, I think.
That's cool.
Yeah.
Okay, so we're gonna do each of these, and we're gonna represent them on number lines. So, shall we go?
Okay.
So, how are we gonna? Let's solve it first. So when we solve it, what does that come out to be?
Wait, should I say it or
Yeah,
work it
please
out?
do. Yeah, we can say it.
Okay, so -7 on both sides.
Mm-hmm.
So that's 4x is smaller than 4.
Mm-hmm.
Then we divide both sides by 4.
Yep.
So x equals 1.
X what?
Is smaller than 1.
Yes. Okay, and then now we just draw a number line, and then we have the number 1, 0, -1, -2, -3, and so on. And here we have 1, oh gosh, 2, 3, 4. Here, is x allowed to be equal to 1 or not?
No.
It can't because it's strictly less than. So what we do is we draw an open circle at the 1,
Okay.
and then we draw a line, an arrow going that way. That's it. It just means x is less than 1. That's all it is.
Okay.
Now let's look at the next one. I think we'll look at all 4 of these because they all have different inequality symbols.
If it's less than 1 or greater, how far do you do the number line? Only to 3?
I mean, I notice how I put ... as well. to show that the numbers do carry on.
Oh yeah.
Yeah, like you can go as far as you want, but the arrow has just like I've drawn a line and I've just also got an arrow. I'll show
Yeah.
you what other types of inequality number lines will look like when we have like two inequalities, for example.
Okay.
Yeah, we'll look at some of those later on. Cool. Okay. So the next one then, how are we going to start?
Add 2 on both sides.
Yep.
So that'll be 3x is greater than or equal to 12.
Yep.
So then you divide 3 on both sides. So that'll be x equals is greater than or equals to 4.
Lovely. And then we've got our number line here. We're going to draw. Let me just actually do this. So 4, 5, 6, 7, 8, ... and so on. 3, 2, 1, 0, and so on. Okay, now what we're going to do is we're going to draw a circle at 4, but this time we're going to color it in because that includes the 4 because it's greater than or equal to, and then we draw our arrow going this way because it's greater than.
Okay.
That's it.
So the arrow has to go all the way to the end of your number line.
Yeah, I mean, we've got an arrow and it just keeps going. The fact that there's an arrow means it just goes on forever.
Okay.
So again, when the line has to stop at a certain place, I'll show you what that looks like.
Okay.
Okay. Next example.
So you have to add 3 on both sides.
Yep.
So x over 2 is greater than 3.
Yep. Lovely.
So then you multiply 2 on both sides. So that's x is greater than 6.
Yep. And what's our number line going to look like?
Should I draw it?
Oh yeah, if you can, that'll be even better.
Oh, I'm on the wrong page.
It's slide 3.
Okay. I don't think I can draw it well.
That's okay. It's looking fine so far.
Yeah, I can't draw the rest of the numbers.
Okay, I can draw it for you. Nice. So yeah, the point is, you've drawn. Okay, let me just clear.
I didn't call. Oh wait.
So you've drawn your circle at 6, and you were right to not color it in because it's strictly greater than 6. So that's good.
Okay.
Okay.
Okay, so we multiply 4 on both sides.
So what do we get?
X plus 18 is smaller than or equal to 20.
Yep.
Then we minus 18 on both sides. So x is smaller than or greater or equal to 2.
And then let me draw the number line, and then you can maybe draw the inequality.
Okay. Wait. I don't know if the arrow is the right way.
Okay, well, how did you decide which way the arrow goes?
Oh. Oh, I did it wrong. Sorry.
Okay.
It's because x is smaller than
Okay.
2. How do I rub it out?
You can just press Control Z. And again.
Okay.
Mhm. Okay. Okay, so yep, we go to the left because it's smaller than or equal to 2. And you you can think about it as your thing is gonna actually no, let me not say that. Yeah, because it's smaller than or equal to 2, you point the arrow to the left. Why did you color it in?
Because it's equal.
Hmm. Perfect. That works.
The ideal.
Okay, so oops. Right. Yeah, I think that's fine for now. We'll carry on. And then we'll get to some other types of inequalities where we've got to draw the thing in, and then we'll see how to draw in the inequality symbols for those as well. So I guess we'll come back. Yeah, we're going to go back to just solving inequalities.
Okay.
Right, so slide 4. What do we have? Or what methods did we go through?
I expanded it first.
Okay, so you got what when you expanded?
5x minus 15 is greater than or equal to 40.
Indeed. And then?
Added 15 on both sides.
Mm-hmm.
So that'll be 5x is greater than or equal to 55.
Yes, it is.
And then now you divide 5 on both sides.
Mm-hmm.
So x is 11.
Yeah, very good. That's it.
And then for the next one, I'd got 6x plus 12
Yep,
is smaller than 42.
indeed.
Then I minus 12 on both sides.
Mm-hmm.
So that's 6x is smaller than 30.
Yep.
Then divided 6 on both sides.
Mm-hmm.
So x is smaller than 5.
Very good.
So the next one, I got 10x plus 2
Mm-hmm.
is smaller than or equal to 36.
Mm-hmm.
So I minus 2 from both sides.
Mm-hmm.
So that's 10x is smaller than or equal to 34.
Mm-hmm.
So divide 10 on both sides,
Mm-hmm.
and that's x is smaller than or equal to
Mm-hmm.
3.4.
Very good. Yeah, you've got this. I'm confident. I think you've got the other one. So I'll just race through those really quickly, unless
Okay.
you wanted to answer one of them.
Oh, I didn't finish working it out.
That's cool. I'll just go through these.
Yeah.
So expanding, we get 4x minus 8 is less than 18. Adding 8 to both sides gives us 4x is less than 26. X is less than 26 over 4, or is less than 13 over 2. Next one, we have expanding, we get 4x minus 18 is greater than or equal to 22. Adding 18 on both sides, we get 4x is greater than or equal to 40. Then dividing by 4, we get x is greater than or equal to 10. And then with the very last one, expanding, we get 6x plus 21 is less than or equal to 9. Taking 21 away from both sides, we get 6x is less than or equal to minus 12. And then dividing by 6, we get x is less than or equal to minus 2. Did any of these look complicated, or was it all good?
It was good.
Lovely. Okay. Next one is slide 5. It's a bit more interesting. This one you've got to be very, very, very careful. I say this, one way to avoid any danger is the problem is you've got x's on both sides of the inequality. What I'd recommend, and it's what I recommend for solving equations, so you can carry on with solving inequalities, is look for the side that has the smaller number of x's and eliminate the x's from that side.
Oh yeah.
So with the first one, for example, you've got 4x on one side and 2x on the other. If I take away 2x from both sides, I end up with 2x plus 3 is greater than 11. Now I'm all good. I've got a coefficient of x, which is a positive number, so there are no potential problems that I'm going to fall down.
Okay.
And taking away 3 from both sides, I get 2x is greater than 8. Dividing by 2, I get x is greater than 4. Can you talk me through the second one?
You minus x on both sides
Okay, why are we minusing x and not minusing 3x?
because it's the smaller
Yep.
thing.
Yep, it's the smaller one of the two.
So that'll be 2x minus 18 is smaller than or equal to 1.
Oh, okay. I like how you said that way around. So when you said it, did you mean it like this? 2x minus 18 is smaller than or equal to 1. Like that, is that what you meant?
Yeah.
Why did you do it that way?
Because I switched it round so that 1 was what was because on the normal the way that the question was set, it says that it 1x plus 1 is greater than or equal to 3x minus 18.
That's cool. That works. Okay. The fact that you were able to spot that, that's really good. That's very, very good actually. You can keep doing it that way if you wish. I'll do it another way just to help, but if you prefer doing it the way you do it, then please carry on. But I just propose doing this. So if you take away x from both sides, I just leave 1 on the left, keep the sign like this, and then 2x is minus 18. Does looking at like this bother you?
Oh no.
Okay, cool. So I guess we'll keep going like this then. And then what would you do from here?
Add 18 on both sides.
Lovely. So we get 19 is greater than or equal to 2x.
Then divide by 2 on both sides.
Yes. So 9.5 is greater than or equal to x.
Yeah.
Equally, if we had done it the other way that you'd mentioned, another way in which you can lay out this inequality is x is less than or equal to 9.5. They both mean the same thing because in both instances, the inequality is pointing at the x or it's pointing away from the 9.5, or the crocodile eats the 9.5, it eats the bigger one. However, people like to memorize which way the inequality goes. Okay, that's good. What about the next one?
You would minus 3x on both sides.
Yeah.
So that'll be 10x minus 12 is smaller than 13.
Very good.
So what's it? You add 12 on both sides. So that would be 10x is smaller than 25. Then divide by 10 on both sides. X is smaller than 2.5.
Yeah. Very nice. Yeah, you seem to be managing these very well.
So on D, you'll minus by 3x on both sides.
So minus 3x on both sides, and that gives you
4x minus 5
Yep.
is greater than or equal to 11. So you add 5 on both sides. 4x is greater than or equal to 16. So divide 4 by 4 on both sides. X is greater than or equal to 4.
Cool. Yeah, you're managing these really well. Next one. Find the largest integer on slide 6. Find the largest integer that satisfies each inequality below. So we are solving the inequalities as before. So in this case, taking away 3 from both sides, we get x is less than 6. So the largest integer, do you know what integer means?
Number?
Yeah, what kind of number?
A whole number.
Whole number, yes. So any whole number, positive, negative, and 0. X is less than 6. So the largest integer, do you know what the largest integer would be then?
5.
Yes. I'm glad you stopped yourself from saying 6. So yeah, largest integer is 5. That's it. Next one, if we solve that, how would we solve this?
Minus 5 both sides. 2x is smaller than 7.
Yep.
Then divide it by 2. X is x is smaller than 3.5.
Very good.
So it would be 3.
Yep. Very good. Largest integer equals 3. And then the last one.
And then next one, minus 10 on both sides. So 7x is smaller than or equal to 21. Then divide by 7, which x is smaller than or equal to 3.
Yes.
So the largest integer is 3.
Yes, the largest integer
Integer.
equals 3. That's it. Good stuff. Okay. Same question again. What's the largest integer? So yeah, we're just solving the next one on slide 7.
Where I should do it.
Yeah, you can explain to me. Oh, you're gonna do it on paper yourself?
Oh yeah. Or should I write it?
If you can write, you can write, but if you prefer to tell me and I write, we can do that. However you want to do it.
Okay, I'll tell you.
Okay. I'm listening, I'm ready.
So you're minus 1 on both sides.
Yep.
Which is 7x is greater than 59. So you divide by 7 on both sides. And then
No.
1 second.
Okay. Let me also be annoying and say that we're not allowed to use a calculator.
I'm using on paper.
Oh, okay, cool.
Would it be 8.2?
Okay, let's check. So let's apply the bus stop method. So 7 into 59. That's not a square root sign. It's supposed to be a bus stop method division sign.
8.28.
What's that? Let's check. So 7 into 56, because we can't do it into 5. That goes in 8 times. The remainder is 3, so that goes next to a 0. 7
I put 2 by mistake.
No problem. 7 into 30 goes in 4 times. Remainder 2. And then 7 into 20 goes in twice. Remainder 6. 7 into 60 goes in 8 times, and so on. So it's 8 and a bit. And if x has to be greater than this, then what's the integer that satisfies?
Wait, it has to be. Wait, what was the question? Sorry.
What's the smallest integer that satisfies? Oh, this one was found as the largest. This one should be found as smallest. I should have put that actually up there. That would have been. Sorry, I didn't actually put the question up.
8. 7.
If it's got to be greater than 8.42 something.
I'm not sure.
Well, this one's going to be 9. Because if it's greater than 8 and a bit, right? Because this one's greater than, right?
Mm-hmm.
But it's okay, no worries. Let's go for the next one.
Oh, okay. So you add 16 on both sides.
Mm-hmm.
So that would be 10x is greater than or equal to 992.
Yep.
So divide 10 on both sides.
Mm-hmm.
X is greater than or equal to 9.2.
Yep.
So would it be 10?
Yes. So the smallest integer equals 10. Okay, and then the next one.
We take minus 7.7x on both sides.
Okay, why is that?
Because it's the smallest.
Yep, smaller one of the two. Lovely.
Yeah. So that would be 2x plus 4.
Mm-hmm.
It's greater than 15.
Yep.
So you minus 4 on both sides.
Yep.
So that's 2x is greater than 11.
Yep.
So divided by 2, that's 5.5.
Yep, x is greater than 5.5.
So the smallest integer will be 6.
Lovely. Smallest integer equals 6. Lovely stuff. Is that okay for you? Does that make sense?
Yeah.
Cool. Right, next one. They've only asked us to solve the inequalities, but I'm actually going to ask us to not only solve it, but also represent them on a number line, just so that you get an idea as to what happens when you have this kind of inequality.
Okay.
So, just like the other equations, rather than doing the same thing to both sides, we're going to do the same thing to all 3 sides.
Okay.
So, for example, the first one,
You minus 3 by on 6,
mm-hmm.
X and 10.
Yep. So the left hand, the middle bit, and the right hand side. So
Yeah.
taking away 3 gives us taking away 3 gives us 3 on the left.
3x and is smaller than 7.
That's it. So x is in between 3 and 7.
Yeah.
And an inequality symbol would look like this. Inequality number line, sorry, would look like this. So we put a 3 here, 4, 5, 6, 7. Let's just put some other numbers and so on. Okay, so I'm actually going to put here an open circle at 3 and an open circle at 7, and then draw a line like that. And that's it.
Okay.
So the numbers carry on here, the numbers carry on here. But this line has an ending because it's bound.
Oh yeah.
So there we go. Right. B.
So would you divide by 2 on all sides? So that would be 2 is smaller than or equal to x.
Yeah.
Is smaller than or equal to 3.5.
Yep. And again, if we were to use a number line, bit of a weird one because there's decimals involved, but no worries. We'll just count up in 2.5. So 2, 2.5, 3, 3.5, 4, 4.5, 1.5, 1, 0.5, and so on. Okay, so I'm going to color the 2. And let me ask you a question. What else am I going to do?
Color go up to 3.5 and color the circle as well.
Yeah, very good. And then
draw the line.
Yep. Draw the line in between. That's it. And then where else? Okay. We've got one more to do. May as well do this one as well.
Divide by 3 on the side.
Yeah. And what does that give us?
In decimals. Or?
As a fraction is nice. This
Okay.
decimal could be a horrible decimal. Well, not horrible, but I didn't like it as a decimal.
1/3.
Yep, a third.
Is smaller than or equal to x. Which is smaller than 3.
And then again, similar kind of thing. Let's see, a third, 2/3, 1, 1 1/3, 1 2/3, 2, 2 1/3, 2 2/3, 3, 3 1/3. Got 0 here and then minus a third. Okay, and how are we going to draw the inequality symbol?
On the third, you'll draw a colored dot. Then on the 3, it will be an open.
Lovely, yeah, that's it. And
then you'll draw a line.
That's it. Nice. That's pretty much how that goes. Yeah. You're good with that. How do you feel about the inequalities now?
Yeah, it's good. I understand it.
That's good. That's what we want. Yeah, I'm glad. I'm glad to hear it. And what I'll do is with the rest of the questions, I will answer them. Yeah, I'll answer them and I'll upload these to YouTube. And then if you want to see the rest of it, you can.
Okay.
Yeah, nicely done.
Thank you.
Very, very well done. Coolio. I guess I'll see you next week.
Okay. Yeah.
Awesome. Lovely stuff.
Thank you. Bye.
You're very welcome. Take care. Bye bye. Okay, so moving on to the next question, just really, really quickly. Just solving the inequalities. I'm not going to use the number lines this time. I'm just going to solve them. So multiplying everything by 5, I get 20 is less than x less than 30, just timesing through by 5. Here, taking 3 away from everything, I get 6 less than or equal to 2x less than or equal to 22. Then I'm going to divide everything through by 2. So I get 3 is less than or equal to x less than or equal to 11. Okay. Then next, I'm going to add 1 to everything. So this is minus 2, because minus 3 plus 1 is minus 2. Watch out for those negative guys. Negatives, guys. Is less than or equal to x over 4, which is less than 1. Adding 1 to 0 is 1. And then timesing by 4, I get minus 8 is less than or equal to x, which is less than 4. And that's it for that one. Next, find the integers that satisfy each of the inequalities below. Well, this one's good. So we're not allowed 5, but we can have 6. We can have 7. We can have 8. We can't have 9 because it's not including 9. The next one, we're not allowed minus 3, but we can have minus 2, minus 1, 0. We can have 1 because it's less than or equal to 1. Then the next one, before I can work it out, I'm actually just going to divide everything by 2. So I get 2 is less than or equal to x, which is less than or equal to 4, because I've divided everything by 2. And then I see here that I'm allowed to have 2, I'm allowed to have 3, and I'm allowed to have 4. Cool. Same question, find the integers that satisfy each of these. I'm going to take away 1 from everything. So it gives me 15 is less than or equal to 5x, less than 30. Dividing everything by 5, I get 3 is less than or equal to x is less than 6. And the integers I am allowed are 3, 4, 5. 3 because it's less than or equal to, but 6 no because it's strictly less than. Okay, next one. If I times everything by 2, I get 0 is less than or equal to x minus 6 less than 4. If I add 6 to everything, I get 6 is less than or equal to x is less than 10. So here I am allowed 6 because it's less than or equal to 7, 8, 9. I'm not allowed 10 because it says less than. And then finally, if I add 1 to both sides, I get, oh gosh, what do I get? I get minus 8 is less than x over 4, which is less than minus 7. Timesing everything by 4, I get minus 32 is less than x less than minus 28. So therefore, I'm not allowed minus 32, but I am allowed minus 31. I am allowed minus 30, minus 29, and I'm not allowed minus 28. And that's it. That completes our little section there on inequalities. So hopefully you have a better understanding of solving inequalities and just representing inequalities on number lines and being able to solve with inequalities that are like sandwiched in between. That's the basics for it. Take care for now. Bye-bye.